direction fields or slope fields. So first of all, the direction fields, what do they represent? Have you seen a direction field?
No, I've never heard of it before.
Okay. So I'll show it to you first.
Okay.
We'll go to, there is a tool called GeoGebra.
Oh, I think I've heard of it before, yeah.
See, you can see this is a slope field. This green, not green line, but the tiny black straight lines that you see,
Mm-hmm.
those are the slope fields. That is the slope field. Okay.
Oh,
This is what we will have to draw. Now, what do these represent? It shows you the slope of all the solutions, that we get of a differential equation. So yesterday we did differential equations. Okay.
mm-hmm.
Let me take an example. dy over dx is equal to 2x. Okay.
Mm-hmm.
If you want to solve this equation, can you tell me the general solution of this differential equation? You can use separable equations.
Okay. It would just be, well, dy equals 2x dx, so integrating that would just be y equals, bring the 2 out, so then y equals x squared plus c.
X squared plus c, exactly. Okay. Now, this is the solution, okay?
Yeah.
Now, the slope field that we draw, that slope fields gives us the slope of, so, okay, now, if I take different values of c, if I take c is equal to 1, I'm going to get y is equal to x squared plus 1. If I take c is equal to 2, I'll get y is equal to x squared plus 2, right? X squared plus c is a general solution, and all of these are particular solutions. Okay. Now, I'm going to draw the slope field on GeoGebra first to make you understand the meaning of the slope fields, and then I will tell you how to draw it without GeoGebra, because on your exam you'll have to draw it without GeoGebra. So here, you can type the equation. Our equation was
Y equals x squared plus c.
no, the original differential equation we will plot it.
Dy over dx equals 2x.
So 2x. Okay. Now we got the solution as x squared plus c. Okay.
Yeah.
Now this graph gives us the solution x squared plus c for different values of c.
The lines just look like small tangent lines to the curve, right?
Now you see these lines, the tiny black lines. We will learn how to draw these black lines, but these black lines actually represent the solution. The solution we got was y is equal to x squared plus c. Okay. And at x squared plus c, if you draw different slopes, you're going to get these black lines. And what is x squared? X squared is a parabola, right?
Yeah.
And if you add c, it will keep moving up or it will keep moving down.
Yes.
For different values of c. Okay. If I increase the density. So these black lines represent the slope field. That means the slope of the solution. Okay,
Wouldn't there be infinitely many though?
Yes. And you can actually, from here, we can also change the value of c. Yeah, c. These are all the solutions. There will be infinite solutions. For each value of c, you'll get a different particular solution. Okay?
Yes.
Now, how do we draw these tiny black lines? Well, that's very simple. For that, I will get the grid background. So we have all these points. 1, 2, 3, 4. 1, 2, 3. -1, -2, -3, -1, -2, -3. Now what you have to do is, you have to take any point, any random ordered pair. Let's say you are taking this point, 1, 1.
Okay.
At 1, 1, x value is 1 and y value is also 1. So what you will do is, you will put it in this function. X is 1, y is also 1. So 2 times x gives you 2 times 1, which is 2.
Yes.
So that means dy over dx at 1
Equals.
comma 1 at 1
Yeah.
comma 1 is 2. That means the slope of the solution, dy over dx is what? Dy over dx is slope.
Mm-hmm.
So the slope of the original function, which was this, at 1 comma 1 is 2. So at this point, we have to draw a tiny line with a slope of 2. Okay, so with a slope of 2, that means it will be slightly steeper. Okay, now you have to do this for many points. Okay, now if you see, if you take all of these points, 1 comma 2, 1 comma 3, what will be the slopes that you get?
1 comma 2.
We'll do this. Now we'll draw the slope for all these points. 1 comma 2, 1 comma 3, 1 comma negative 3. At 1 comma 2, the slope will be, so your equation is 2x. Okay, so you do 2 at 1 comma 2,
It's
the slope
just
will be
2.
also 2, right? And in fact, if you see all these points, 1 comma 2, 2 comma 2, sorry, this is 1 comma 2, this is 1 comma 3, this is 1 comma negative 1, 1 comma negative 2, 1 comma negative 3. And since our differential equation is 2x, so it doesn't matter what is the y value. Right now, here you'll get the slope as 2 for all these points.
Mhm.
So you can draw tiny line, tiny straight line with a slope of 2
Okay.
on these points. Okay, now if you take these points 2 comma 1, 2 comma 2, 2 comma 3, what will be the slope?
So 2 comma 3. That would be just 4.
4. Let's take 2 comma 2, 2 comma 3, 2 comma 1, any point. We will get the slope of 4.
4.
Now 4 is even much steeper than 2 because slope of 4 is even steeper than slope of 2, right? So, you know what you can also do is you are standing here. Slope is what? Rise over run,
Mm-hmm.
right? So this is 4 over 1. So you have to keep your eyes on a point which is 4 units above. So 1, 2, 3, 4. Imagine that you have to connect this point. So you would draw a line like this. It will be
Okay.
steeper than 2, right? This is how you will draw. Okay?
That's very odd. Okay.
And this is like very simple but still annoying. Okay, now we will take the points which have x coordinate 0.
Okay.
Okay, like the points on the y-axis, right? So 0 comma 1, 0 comma 2, 0 comma 3, 0 comma
There'll
negative
always be 0.
0. So the slope will be 0. So we will draw a line which has a slope 0. So that is a horizontal line. So on the
Mhm.
y-axis, you will get these lines.
Okay.
Okay. Now if you take the points on the left hand side, or so for example, negative 1 comma 1, negative 1 comma 2, negative 1 comma 3, you'll get the slope of negative 2. Okay.
Yes.
So that will be, those lines will be like exactly this line, but just a mirror image.
Mm-hmm.
And it's very difficult to draw it on the opposite direction. Okay. And similarly, here you'll get negative 4, even more steeper line here. And I'm leaving the points on the x-axis for now.
Okay.
Now on the x-axis, what kind of coordinates we have? Well, 1 comma 0, 2 comma 0. So yeah, that will not change. This will be 2. This will be 4. This will be negative 2, negative 4, and so on. So you can
Yes.
see these tiny lines actually give you, and if you take any single point, you kind of get a graph. On the left hand side, you can see it will have this type of graph. This is the solution that you will get, a parabola.
Mm-hmm.
And these tiny lines represent the slope of the solution at any particular point.
Okay.
Now, if you go on GeoGebra, if I remove all these solutions, see that's what you have. On the y-axis, you have horizontal lines, right? All the points on y-axis, they are horizontal. And if
Mhm.
you see these slopes, and if you go, like if you keep moving on the right hand side, the lines keep becoming more and more steep,
Okay.
right?
Mm-hmm.
That's where the slope, because the slope is increasing. As we keep increasing the x values, the slope keeps increasing. That's how we draw the direction field. So these tiny red dots, these are the direction fields.
Okay, makes sense.
Okay. Now here we only had X. We did not have Y. So it was easier to draw the direction fields. Okay.
Mm-hmm.
Now let's take some other examples in which we will have both X and Y.
Okay.
So let's take dy over dx equals xy. Okay. You don't need to solve the differential equation in order to plot the direction field. Okay.
Okay. Yeah.
You just have to take ordered pairs.
Mm-hmm. So this will just all be graphing then?
Yes.
Oh no.
Why you don't like graphing?
No, I'm very bad at it.
But this is very simple.
That's true, but I don't know. I generally don't like graphing that much.
Okay. Okay. So if you have xy, now you have x and y. So now again take any random point. If you take 1 comma 1, you'll get slope you'll get as 1.
So when you say 1 comma 1, what does the y coordinate do in this?
When I say 1 comma 1, that means this is the x coordinate and this is the y coordinate. So in this equation of differential equation, you put x is equal to 1 and y is equal to 1. Okay,
Mm-hmm. So that would just be the differential of 1?
that will be 1. Okay, so that means dy over dx is equal to 1. We have to plot this.
Uh-huh.
Okay, now, and you can think about it. If you even try to solve this differential equation, you are going to get y is equal to 1 dx, that will be x plus c. That means this is a straight line, y is equal to x plus c, and it is passing through the point 1 comma 1. So you have to draw a straight line, okay,
Mm-hmm.
passing through the point 1 comma 1, and it also has slope of 1. This is the slope. So this will be the line. Now draw a tiny line. I'll use red color, wait, with a slope of 1. So you have to keep your cursor here and imagine that you're trying to connect this point and this point because you have a slope of 1, right?
Mm-hmm.
So that's your line.
Okay.
Okay. Okay. At 1 comma 2, so take x 1 and y as 2. So the slope will be 2. So 1 comma 2 is this point. Now it is slope is 2. So you keep your cursor here and try to draw the straight line as if you're trying to connect this point. See rise
Okay.
over run, right?
Yeah, yeah, yeah.
So if you're trying to connect that point, you'll get this sort of a line, right? Then
Mm-hmm.
3 comma 1, I'm sorry, 1 comma 3, rise over run. So try to connect this point.
So for
Much,
this one, the lines would just keep increasing in slope?
yes. And then if you take the points on the x-axis, you'll have the points will be, you see this point is 1 comma 0, 2 comma 0, 3 comma 0. Y coordinate will be 0 on the x-axis.
Okay.
So the dy over dx will become 0 for all the points on the x-axis. So all the points on the x-axis will have horizontal line.
Mm-hmm.
Same thing will happen for all the points on the y-axis, because on the y-axis the points are of the form 0 comma 1, 0 comma 2, 0 comma 3. These are all the points on the y-axis. So if you do x
How would
times,
you know? Sorry. How would you know if the slashes like have the accurate slope?
when you're drawing the slashes, there's no way to guarantee that you will draw the slashes with accurate slope. And
Okay.
yeah, if you want, you can use a scale, like keep a ruler at this point and try to connect it with this point and then draw a slash.
Okay.
But that will be very time consuming.
Yeah.
So on the y-axis also the slope will be 0. Okay. And
Okay.
this is how you have to do for all the points.
Oh, okay.
Okay. If you
Yeah,
see
I
this,
understand it. I just don't want to do it.
yeah, it's not something that
How
You
do
would,
you put questions like this on a test?
why? That's, you can put questions. You'll have to draw
Would
the,
the question just be to draw the slope field?
yes,
Oh, okay.
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 And so see, this is the slope field for x, y. For different values of c, you will get this. And if you try to solve this, if you try to solve this differential equation, what do you have? dy over dx equals to xy. This is a separable equation, so you'll get dy over y is equal to x dx. dy over y is ln y, x squared over 2 plus c. Y is equal to e raised to x squared over 2 plus c. That this is the graph for different values of c. Graph of y is equal to e raised to x squared over 2.
Okay.
Okay.
Wait, does that say E or C? Oh, okay. E. Okay.
Hmm.
Understand.
Okay. Now, some questions can be also asked like this. The slope field would be given.
Uh-huh.
And so I'm going to give you a slope field of dy over dx equals 1 minus xy.
Mhm.
Okay. And the function, oh, you have a function f, which is the solution of this differential equation. Okay. We have to write the equation of a tangent line to f of x at the point -1 comma -2,
Mm-hmm.
and its slope field is given to us,
Okay.
slope field of this differential equation. We have to find out the equation of the tangent line at -1 -2. Where is -1 -2?
Right
This is
there.
-1 is this,
Yep.
-2
Negative
is
2 is there. Yep.
okay. And you first, so you need to think first, how will you write the equation of the tangent line? You know that you will be using the point slope form. Y minus y1 is equal to m times x minus x1, because they have already given us 1 point. So you know the values of x1 and y1. That's
Yep.
x1, that's y1. You need the value of m. So how will you get the value of m?
The value of M, you just differentiate it.
No, m will be what? M will be the slope of the tangent line drawn at this point, right?
Okay.
So if this is
Oh,
the point,
so differentiate the. No, never mind. Please continue.
so see this point, if you can find out the slope of a tangent line drawn at this point, see, these are small tangent lines only. You just have
Mm-hmm.
to find out what will be the slope of tangent line drawn at this point.
Yeah.
And you can do that by plugging in that point in this equation. This equation is actually giving you the slope of the tangent lines at all the different points.
Right.
So if you plug in -1 comma -2 in this equation, that will give you the slope of the tangent line to the curve.
Okay.
Okay, so 1 minus -1 times -2. So 1, -1 times -2 will be +2. So
Mm-hmm.
1 minus +2, that's -1. So this tiny slash mark will have a slope of -1. Okay. And if this green curve passes through this point, like for any different value of c, so the slope of the tangent at that point will be -1.
Mm-hmm.
So your equation of the tangent line will be y minus y1, which is -2, equals -1 times x minus x1. x1 is again -1. So you can simplify this. This will be y plus 2 negative x plus 1. This is the equation of the tangent line.
Hmm. Okay.
Okay.
Mhm.
Okay, this was the slope fields.